Welcome to this tutorial on provisioning an EKS cluster on AWS using gopaddle. Before we dive into the steps for provisioning an EKS cluster, I would like to introduce you to the types of node pools and the roles. Later in this session, I will walk you through the steps to provision an EKS cluster, how to update and troubleshoot the cluster, and then introduce you to the concept of add-ons. Node pools, as you know, are a logical grouping of nodes within a cluster that share the same set of configurations. gopaddle supports three types of node pools. First one is the managed node pool that comes with the default EKS optimized Amazon Linux AMI. These are similar to the node pools that are provisioned directly from the AWS console. We call these node pools as managed, as AWS maintains these Amazon machine images. The next type of node pools are called custom node pools. These node pools use user-provided AMIs, which are maintained by the end user. The last type of node pools are called storage node pools. These are custom node pools, but with additional capability to automatically provision and configure storage clusters. Storage offers a distributed storage for cloud-native applications. By provisioning a storage node pool, you do not have to worry about configuring the persistent volume layer when the cluster scales up or scales down. You can create an EKS cluster with one or more of each of these node pool types. Coming to the roles, we have three different types of roles. Master role is used to provision an EKS master node. Node pool role is used to provision a managed or a custom node pool. And the storage role is used to provision a storage node pool. It is recommended to create a new master role for each cluster. And within a cluster you can reuse the node pool roles to create node pools. Let us now start provisioning an EKS cluster. I will be demonstrating the steps for creating an EKS cluster with managed node pool. This requires an AWS account to be pre-registered with gopaddle. In the gopaddle console, under the infrastructure section, choose cluster and create a new cluster. Select the provider as AWS and choose the cloud account. Click on Create Master Role. This will redirect you to the AWS console. Confirm the IAM role creation process. Once the role is created, copy the role ARN output. In the gopaddle console, provide this ARN for the master role. Select a region and enter the CIDR address range for VPC and subnets. gopaddle automatically creates a VPC in the selected region with maximum 3 subnets. 1 subnet per availability zone. If a region has only 2 availability zones, then only 2 subnets are created. As the next step, we need to specify the disk size for each node, the minimum and maximum number of nodes in the node pool, the desired number of nodes that need to be provisioned as soon as the node pool is created. I will be provisioning a managed node pool. But if you need a custom node pool, choose the custom AMI option. We have a list of Ubuntu AMIs that are compatible with Kubernetes version 1.18. In the gopaddle help document, search for EKS. In the Creating an EKS Node Pool document, select the custom AMI link. You can review the Ubuntu images suitable for a specific cluster version and a region. Since we are creating a managed node pool, we need to deselect the custom AMI option. Select the instance type and the availability zones. Similar to the master role, we must now create a node pool role. Click on Create Node Role to create a node pool role. Add the role ARN and click Finish. This will initiate the EKS cluster provisioning activity, which might take 15 to 20 minutes to complete. Once the cluster is provisioned, you can start managing the cluster from the gopaddle console. You can get the kubeconfig file to access the cluster directly using kubectl. You can review the VPC and subnet details under the VPC tab. Under the nodepools tab, you can view or add nodepools to the cluster. Under nodepools, you can view the list of nodes, their consumption, labels, Docker images, and the logs. Under the add-ons section, you can view the add-ons that are automatically provisioned by gopaddle at the time of creating the cluster. In order to access the Grafana dashboard, open the necessary firewall ports in the security group. In the AWS console, edit the EKS Remote Access Security Group and grant inbound access to port 32,000. You can now access the Grafana dashboard. Moving on to debugging cluster issues, gopaddle provides activities and logs for troubleshooting issues. The Activities tab gives the list of gopaddle tasks. The Logs section gives different levels of logs like the VPC logs, autoscaling or nodepool logs. In case of a storage nodepool, you would also get SSM logs. This brings us to the end of this tutorial on provisioning and managing EKS clusters using gopaddle.